Welcome to Hanover. It's a pleasure to be here today. So we're going to spend a few minutes talking about the digital twin. But before we get started, I think everybody who came in from the airport today, and you see this, there's a lot of people, you can relate to the slide on the stage. And if you think about all of these people, it kind of goes back to what could happen when you have a lot of chaos going on at one time. Imagine this is your supply chain, and something just happens to break down, like security or TSA or baggage check. And so you have these long lines backing up. Well, where we've come from the consumer internet is now everyone will pull out their smartphone and they'll be tweeting, why can't I get through security? Why am I missing my flight? So when you sit back and think, now we're doing this same type of thing with industrial equipment. We have the ability to tie things together in a more seamless manner. So if you think about where we've been, it hasn't been that long that we really started connecting devices together. We started out with about 350 some odd million components that were connected. But it really started to get interesting when we moved into the IP6 arena and we started to get a lot of mobile devices. That's when you started to see these numbers dramatically increase. But what we see today compared to what is happening in our collective industries is quite remarkable. If you look out a couple more years, by 2020, there are going to be around 50 billion connected devices. So like all of those people we saw standing in the queue, we will all be connected somehow, some way. All of our equipment is connected somehow, some way. Well, what does that create? Well, it's a lot of data. So if you sit back and think about data, how quickly it's going to increase, from last year until 2020, in 4 years, it's going to more than double. The number of devices, the amount of information that we're getting. And what that creates is a lot of data. And you'll hear folks say that perhaps we create data lakes, or we just go out and buy our favorite analytic tools and we can solve all of these problems. Let me give you an example of what we're talking about in terms of the amount of data. One GE turbine can create about 500 gigs of data every day. That's one. So imagine a large plant, a large facility, a large manufacturing concern. You're putting out a lot of data. So with that, you have to make the data make sense. And what happens in a lot of cases, folks get overwhelmed with data. They can't separate what's normal, what's a false positive, and what's going to be great operational procedures. That's how Industrie 4.0 and the industrial internet are coming together. To build a platform that's going to allow you to make sense of this data, you have to build a digital thread in between the components. What that digital thread will allow you to do is think about how a piece of equipment was designed, the physics of how it was created in the factory, from when it was manufactured, designed, all the way to the end of life, in every step along the way. Simply coming out and looking at the data is not good enough. If you look at the amount and the numbers of sensors, walk around the show floor here, everyone has sensors. There are sensors as small as the tip of my finger. So with that, you start to see the collection of data, and that's how we get those 50 billion connected devices within the next couple of years. The important thing is when we think about our industry, is what do we do with that data? How do you put it within the context of what we do every day, from Industrial 4.0 to the industrial internet? And there's many ways to conceptualize data. Is it coming off my historian? Is it a vibration monitor? What exactly is it? Is it affecting my manufacturing plant, my SCADA system? Think about all the components you work with every day. There's a lot of data. And different people within your organization will look at this data in different ways. A plant manager may have one point of view. A reliability engineer may have yet another point of view. The CFO is still going to have another point of view. So think about all of the data sources, the amount of data that's coming in, and what do you do with it? So once again, that thread that ties these things together, from the design to the actual usage, is very important. because that gives us the ability to sit back and look at equipment and look at data in a new light. If we know how these components were designed, if we know how these components were built, we know the failure codes, we know the operating procedures, then we can sit back and look at historical components of how you use them every day. And then we can build algorithms that's actually looking at the data in an advanced analytic form that'll come back and give you greater insights into the data. In many ways, now we can take this thread and predict things long before they happen. We don't have to wait till you get an alarm or a failure code. We can tell you weeks in advance that something is getting ready to have a problem. Why is that important in manufacturing? Why is that important in industry? Because downtime is not good. Okay? You want to make sure that your equipment is operating 7/24. Your supply chain can continue to operate. All of your components are there. How many spares do I need to have? Do I have the right folks online that if something breaks that I can get operational in a matter of moments? Because it's all about outcome. What you're manufacturing, what you're building, what you're producing. So a lot of folks talk about the need to come back and take data and make data make sense. But in order to do this, you have to have a platform that is built to understand data, a platform that allows you to come back, take all of these components and build them together. And this is where the physical world and the analytic world comes together. We'll talk about in just a minute. So what does this mean if I'm an equipment manufacturer? You have your shop floor, you have your top floor. You have your operational cost, you have your profit. How do you lower those costs? If I'm an OEM, I want to make sure that I have increased uptime. Why? Because that's going to help me put more money into the business. It's about my service outcomes. It's about things I want to do and come back and upsell. There's only so much money within an organization. So how do you optimize that? If I'm in operations, it's all about reliability. How do I make sure that that equipment is available 7/24? How do I make sure if I've got a peak production period that things are going to run? We can model things forever. We've had devices on the edge forever. But what's been lacking is the thing that ties them together, from design to end to operations, and then being able to come back and model it in a way that you could actually take what's going on physically in your plant and model it to what's going on in your real time. We've done this with consumer stuff for a long time. I'm sure many of you in your home have like a Nest thermometer that can come back and operate your house. But imagine if we take this same simple concept with these 50 billion connected devices and we start using them in our industry. This is a power example. So now I can come back and I can spot outages as they're actually happening. I can come back and adjust how I'm going to use the grid. I can come back and say whether I need to have more gas turbines online, coal power, renewables, hydro, whatever it takes to make things work. So how do I build these components together to make data make sense? Gartner says this is what a digital twin is. This is when we bring the physical world of the physical equipment and then we bring it to the data that makes things make sense. This is what we're about at GE. We're building a platform, or have built a platform called Predix that does this. Over 500,000 digital twins in operations today. So imagine where we've got these various pieces of equipment, whether it's a turbine, a jet engine. We can come back and actually model what the operation of this component looks like today, and then do the what-if analysis. What happens if I come back and I change these parameters? What happens if these abnormal type of conditions happen? What happens? We can look at different things, like a jet engine example. We have lots of jets flying all over the world. We can do pattern matching. Well, we've noticed that maybe there's a corrosion problem happening on certain routes. Being able to triangulate all that data together, maybe it's because a particular country is seeding clouds. Maybe we have two pumps that come off the same assembly line with two serial numbers apart. One is experiencing a seal leak more so than the other. Could it be things like solidity in the air, terrain concerns? But as we bring all of this data together, we know the operational parameters of what we've built. We know the failure codes of how it's built. We know somewhat the operating parameters of how you operate the equipment. Now being able to come back with these advanced analytics and being able to do machine learning, we can provide insights faster than anyone in the industry. And we do this by many ways. So you sit back and you look at things within your industry. What are the risky piece of equipment you have? So if you sit back many years ago and asked Boeing, when they were putting the 787 together, would they have guessed a lithium battery was the most critical thing that could have grounded the fleet? Perhaps not. But when you look at the balance of plant and you look at the various things that could cause you problems, how do you put parameters around it? And then what is the strategy to make those happen? Once you put these together, that's called asset performance management. By being able to put those together and then monitor them in near real time, we can come back and do interesting insights. We can come back and predict things a lot quicker. We can tell you that you could probably run this piece of equipment a lot longer. We can give you great insights into maybe it's time, if you're an airline, that you need to bring this plane back in because of a slotting strategy that we have availability. Or have spares shipped to a location so that you don't have to maintain excessive spares in all locations. So this is how we think about it. It's iterative, it learns all the time. There are machine learning algorithms in the background that's always looking at this data, comparing what we know to actual operations. And what do? We take that data then, and we can put it back in to give you better insights into how to run your operations. It gives us better insights into how we build our equipment. It gives us better insights to make sure that we're keeping those plants running 7/24. Most of you will probably recognize this as a standard PF curve. And on a PF curve, that's going to tell you how you stay ahead of it. So most of the time, folks look at the machines and the process in that white area. That's running normally. But what happens? I mean, once again, we've instrumented stuff for a long time. You usually get alert right before something's breaking or something has broken. That's too late, okay? You've got a problem at that case. So how do you back that up? So everything that I'm talking about from the digital thread and the digital twin, we're actually coming back and being able to tell way in advance that something is going to happen. Why? We got lots of historic data. We know how things were built. We've got a platform that brings all of these together in a very seamless manner to give you deep insights. So if you look at it, most tagging sensing data looks something like this. That's great. They'll give you an expected value curve, and you can see more times like what your alerting capabilities are going to look like, okay? So this is the way we've done business for a long time. Useful? Somewhat. But imagine if you take this back to that digital thread concept that I was just talking about. Being able to come back and look at things from cradle to grave, beginning to end, how we design it, how do we operate it, what those failure codes. Then, instead of having a situation like this, where you're waiting for an alarm to happen, we can actually sit back and compare many data sources. Maybe it's pressure, flow, temperature, bearing temperature, ambient temperature. Bringing all those together and say, pattern matching, that if this and this happens, chances are something bad is getting ready to happen in your plant or within your operations. That way, we're able to back that early warning up considerably, okay? That way we can come back to you and say, look, we need to have this preventative component in place. You need to have a service call or a maintenance component happening now. You can't wait. But being able to back this up, if you're an OEM, and say, we know within 30 to 60 days we're going to have a piece of, or problem with this particular piece of equipment, then it becomes interesting. Then you can sit back and have your service techs, when they're going out, say, perhaps I've got 12 pieces of that equipment within 3 kilometers of each other. Can you check on A, B, and C while you're out there? You can build more efficiency in your operations. You can make sure that your equipment is running in a more efficient and efficient manner. So this is how we think about the problem. And in a lot of cases, the reason we haven't been able to do this in the past is because we did not have the platform that would enable this. You have to connect it all together. It requires an industrial platform. And that's the reason that we built Predix. Predix is not like a hosted environment. It's a platform as a service that's deeply integrated into everything that we build, every historian we own, every vibration monitor that's in our market, third-party components built on top of this. And then we can come back and bring all of these together as we collect them from whether it's on the plant floor all the way up to the decision-making systems and give you a single view of what's happening. We're combining both real-time with historic data and with our performance plans. This allows you to make interesting insights. Why are we better at this? Because A, this is how we built it. It's not a bolt-on to an existing horizontal platform. This is something that we've taken a lot of time with deep vertical expertise to build. We want to give you those early warning signals a lot faster. We want to make sure that we can give you a platform that you in turn can extend, build out, and add knowledge to. We have lots of algorithms that we're building through our years and years of service and manufacturing company, building things at GE. But we're also working with a lot of partners and a lot of folks in this room to build out new algorithms that can set on this platform, that can take advantage of all this data collection, all the analytics, and all the components that we've built over the years. What industries are twins applicable for? About everything that you do. We've built, once again, over 500,000 of these entities today. We're building what we call twin builders now, where you can actually come back within your organization, look at your normal operation, look at what we've learned, and build out this same type of capability. So think about it. It goes from the physical to the actual operational components, and then everything in between. If someone can't give you that breadth and that digital thread that collects everything together, they're not giving you the ability to build a digital twin. They're basically looking at historic data, or they're looking at operationals data, and they're trying to triangulate. You got to have 3 points to triangulate. That's the reason you got to take the design into consideration, you got to take historical into consideration, and you got to take real-time monitoring into consideration. We just want to make this like a USB port. You plug it in and it works. So if you sit back and look at the GE booth, some of the things that we are building today, you can see where we've started to build this with our APM platform. You can start to see where we're extending this out right now so that folks like yourself can take advantage of Predix and build on top of it. So whether you're an OEM or whether you're a customer, the Predix platform offers a wide range of capability for you to do exactly what we're talking about today. This is an interesting drawing as we think about it, the physical to what's actually operational. This is what a digital twin is. We'd love to talk to you more about this. Visit our booth. We're over in section 12. We'll show you real-life examples of how we're doing this across various verticals. We also would love you to go out and test out what we're doing. Talk to us about possible partnerships, because this is the future. As we sit back and look at everything that's happened from a horizontal, what we've done in the consumer internet, okay, this is much different. This is the industrial internet. Okay, we have to understand every one of these sensors, every one of these points, how they're going to triangulate. So folks will try to confuse you between the two, but there's a big difference. This is why GE built Predix. This is the reason we're betting on the industrial internet. And this cross-section between what's happening in Industry 4.0 and the industrial internet is going to make us all a lot safer, a lot more profitable, and also help protect our planet in new ways that we've never thought about. Thank you so much for your time this morning. Once again, we're in section 12. Please stop by. We'd love to show you what we're doing. Have a great day, and welcome to Hanover.